Guys, I'm Thomas Fernandez and this is Inknex, and in today's video I'm going to teach you about complex numbers. What are complex numbers and why do we need complex numbers? So without further wasting time, let's get started. Each and every set of numbers that we use was discovered for a purpose. Let's start with natural numbers. The set of natural numbers is the numbers starting from 1, 2, 3, 4, 5, which goes on and on and on. This set of numbers was discovered for the purpose of counting. The need of counting is what gave rise to natural numbers. The need of counting things like counting the number of sheep, counting the number of soldiers, or counting the number of gold coins you had. So, natural numbers helped us solve this problem. Once we had the set of natural numbers, there came into existence operations like addition and subtraction, which helped us count much better and much faster. So before we move ahead, I'm going to use some of these operations on natural numbers and see where it leads me. So let me start with addition. Well, I can add simple numbers as 5 plus 7, or which will give me 12, or I can add numbers like 100 and 200, which will give me 300. Well, these are very simple numbers. Even if I add like a 10,000 plus 3,400, it will give me like 13,400. Yes, but if you notice something, all the numbers that I've added there and the sum that I've got, they are all nothing but natural numbers. So when I add natural numbers to a natural number, all I get is a natural number. Now let me try subtraction. Well, let me try simple subtraction as 6 minus 2. Well, that gives me 4. Let me try 100 minus 36. Well, that gives me 64. Now let me try a 10 minus 10. Okay, 10 minus 10, well, I know you'll be saying 0, but if I look at it, I don't have a number 0 in the natural number system. So where did the 0 come from? The 0 came from this exact very need of subtraction of two equal numbers. So the discovery of 0 was down to natural numbers not being sufficient enough for subtraction. But there's one more case that I can bring to your notice. Now let me subtract 10 minus 11. If I subtract 10 minus 11, most of you will know that I'll get an answer which is of minus 1. But this does not belong to the set of natural numbers. This belongs to the set of integers. So, integers was a result of natural numbers failing in the test of subtraction. So now we have a new set of numbers called the integers. So, what are integers? Integers are natural numbers with a 0 put together with the negatives of all the natural numbers on a number line starting from the left with negative numbers and extending towards the right with positive numbers with the 0 in the center. Now that we know integers are sufficient enough for any kind of addition and subtraction, let's move on to the other operations of multiplication and division. I'll start with a simple multiplication, 3 into 2. It will give me 6. Let me try a difficult number. Let's say 18 into 6, it will give me 108. Now let me try 100 into 300, well, that will give me a 30,000. So multiplication, if you note, no matter what number I multiply, it's still an integer. Let's shift our focus to division now. If I divide 60 by 5, what I get is 12. If I divide 120 by 12, what I get is 10. Now let me divide 10 by 4. If you notice that division of 10 by 4 will give me an answer with a remainder or an answer which is not on the number line, which is not a part of the integers. So what do we call such number that is not a part of the integers but caused by division? Well, since it's caused by division, it's a ratio, and such numbers are also called as rational numbers. Okay, so now we have a new set of numbers called the rational numbers. What are rational numbers? Rational numbers are ratios or decimals obtained by division of numbers. Well, you can also obtain rational numbers by finding out square roots or roots of any number. But if you keep on dividing numbers, let me try a different number. Let me say if I divide 10 by 3 instead of 4, what will happen? If I can see, the number goes on and on and on. It goes 3.333333 and on and on. It does not end. It does not give me a number with the remainder as 0. It keeps on increasing to after the decimal place. Such numbers are called recurring numbers. This is also one of the type of numbers. Now if I try further operations like finding square roots of numbers, I can find the square root of 4 as 2. Yes, but what if I find the square root of 2? Well, if I find the square root of 2, it gives me a number that is crazy. Well, if you go to see, it's 1.4 and it keeps on going on and on and on after the decimal place. And also one more thing, the digits do not repeat themselves here. Yes, the digits do not repeat themselves here. So we can neither call them recurring numbers here. So what do we call such numbers? Due to the crazy nature of these numbers, we term them as irrational numbers or numbers that are not rational. So now we have two new sets of numbers called the rational numbers and the irrational numbers. The rational numbers and irrational numbers put together form the set of numbers that we know as real numbers. Real numbers is a comprehensive set of numbers that can be used to solve any mathematical problem. Really? I don't think so. Let me put forward a problem to you and let's see if real numbers can help us solve this problem. So the problem that we're going to solve here is find the value of x if x squared plus 1 is equal to 0. Simple quadratic equation? Yes. There are a lot of methods that can be used to solve quadratic equations. A lot of people who have worked on real numbers and quadratic equations already know them. But what I'm going to do is use a very simple method. I'll take the plus 1 on the left hand side to the right hand side. It becomes minus 1. If we take the square roots on both the sides, what we get is x squared becomes x and minus 1 becomes root of minus 1, the value for which we don't know. There exists no real number that when multiplied with itself gives us a negative number, because we know that a negative number multiplied by a negative number is always a positive number. So for a square to be a negative number, it is impossible. So how do we find out the value of x here? How do we find out the value of root over minus 1 here? This is where real numbers fall short. This is where we need a new set of numbers called the complex numbers. What are complex numbers? Complex numbers are numbers of the form a plus ib, where a and b are your real numbers and I is your imaginary number or the complex bit of your complex number. I is nothing but square root of minus 1. Yes, you heard it right. The square root of minus 1 is I. So if I substitute this value in the equation, what I get is x is equal to root of minus 1, which is in turn equal to I. Yes, we have found out the solution of x square plus 1 equal to 0 as x equal to I. But you may think like, what is this I? I is not a number. Well, so were pi and e before we started accepting them and using them as normal numbers because they helped us solve our problems. And I does the same thing. It helps us solve our problems, especially where our real numbers fail to give us a solution. I steps in and helps us find the solution to what otherwise we considered as the solution does not exist. Yes, you may have read it a lot of times, you may have written it a lot of times. The solution to this quadratic equation does not exist. So my friends, the solution does exist. The solution is in the form of complex numbers. The solution is not on a number line. It is somewhere beyond a number line. It is in a two-dimensional plane that we have never considered the number line to be. We have always considered the number line to be a simple line of numbers stretching from left to right. But we've never considered there could be another dimension to numbers. Another dimension, an imaginary dimension of numbers that could help us solve our problems. This imaginary dimension of numbers, called the complex numbers, makes a lot of problems easier. There are a lot of applications of complex numbers and places that we have progressed solely because of complex numbers. What are those places? What are the applications? That I'm going to teach you in the next video. Till then, what you can do is like our video, share it to the ones who may need it. If you have anything to say, you can write it down in the comments. But please don't forget to subscribe and click on the bell icon. Also, I'd like to inform you, we have our Instagram page, Inknex, the link for which is given in the descriptions below. You can go follow our page, for we'll be uploading a lot of tips and tricks videos on this page, and also there's a lot of quirky content that you can relate to. But don't forget to subscribe and press on the bell icon, because if you don't press on the bell icon, you're missing out on education. Thank you.